Hello everyone, welcome to Epsilon Pro Academy. In today's lesson, we are going to consider organic chemistry past question CHM102, and the question in this paper is not really that visible, so I will read up everything as we proceed. The first section, we have 5 questions. 1, 2, 3, 4, 5. 6 questions rather. So let's start with the first question in the paper. We have arranged the following bonds in order of increasing bond lengths. So we have carbon to carbon, single bond, then carbon to carbon, double bond, then carbon to carbon, triple bond. And in this part, we have carbon to carbon, triple bond, carbon to carbon, double bond, carbon to carbon, single bond. Over here, we have carbon to carbon, double bond, carbon to carbon, triple bond, carbon to carbon, single bond. And over here, we have carbon to carbon, single bond, carbon to carbon, triple bond, carbon to carbon, double bond. Now, bond length depends on bond order. So let's consider what we have here. For example, if we have carbon to carbon, the bond order in this carbon to carbon is equal to 1, simply because we have one stroke. Also, if I have carbon to carbon, double bond, the bond order here is 2, simply because I have double stroke. Also, if I have carbon to carbon, triple bond, the bond order is 3, simply because I have 1, 2, 3 strokes. Haven't known this, bond order is inversely proportional to bond length. That is to say, the higher the bond order, the lower the bond length. Now note, the higher the bond order, the lowest the bond length. So since we are having 1, 2, 3 over here, that is to say this will be the lowest bond length, lowest length, and also over here this will be the lower length, and over here this will be the low length. So we have the lowest, we have the lower, and we have the low. According to the question, we were required to determine the bond lengths increasing order. So this will give lowest before lower, then before low. That is carbon to carbon, triple bond, carbon to carbon, double bond, and carbon to carbon, single bond. So the correct answer in this list is carbon to carbon, triple bond, carbon to carbon, double bond, and carbon to carbon, single bond, which is option B. Now let's consider question number 1II. Functional groups determine. Option A, we have physical state only, we have chemical properties of a compound, we have color of a compound, and we have melting point only. So the question is, what is functional group? Now, functional group is the bond or bonds or atom or group of atoms that determine the chemical behavior or the chemical properties of that compound in organic chemistry. So functional group determine the chemical properties or behavior of that compound in organic chemistry, which is the right answer. Let's move to question number 1, III. A carbon atom bonded to 4 other carbons is called, we have primary carbon, we have secondary carbon, we have tertiary carbon, and we have quaternary carbon. Carbon atoms are classified according to the number of other carbon atoms directly attached to them. So let's consider the types of carbon. We have the degree 1 carbon. This degree 1 carbon is bonded by just or only one carbon atom. So one carbon atom, and it is called the primary. And also we have degree 2 carbon. This degree 2 carbon is bonded by only two carbons, and this is called secondary. Also we have degree 3 carbon. So this is bonded by only three carbons atom, which is called tertiary. Also we have degree 4 carbons. So this is bonded by 4 carbons atom, and this is called quaternary. Let's return back to the question. So the correct answer in question 1II is quaternary carbon. Take note of this. Up next, question number 1IV. Dash was the first organic compound synthesized in the laboratory without the aid of any kind of vital force. So in this question, the correct answer was urea, and it is spelled as UREA. So this was discovered by Frederick Wohler after heating an ammonia cyanide. So the name of the scientist is Frederick Wohler. Now let's know the meaning of halogenation before we can answer the question that is given to us. Halogenation is the reaction in which one or more hydrogen atoms in an alkane, that is paraffin, are replaced by halogen atoms such as chlorine, fluorine, bromine, and so on. Since one atom is substituted or replaced by another atom, it is called a substitution reaction. For example, let's check or write down the reaction. If we have C methane reacting with one of the halogen, let's say chlorine gas CH2, in the presence of ultraviolet light or heat, this is gonna give or yield chloromethyl CH3Cl plus hydrochloric acid or hydrogen chloride. So this is the basic reaction, and the correct option or the final product is going to yield a substitution reaction, which is this. Let's consider the next question. Let's consider question number 1VI. The question is, what is the percentage S character in ethane? We have hint in parentheses sp, sp square and sp cube by hybridization. Option A 20%, B 33.3%, C 25%, and D 50%. The formula for ethane is C dash C. So we have 1, 2, 3, 1, 2, 3, surrounded by or bonded by H hydrogen atom. H, 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 and H. Also note that another way for writing this is CH3, 1, 2, 3H, and CH3, 1, 2, 3H. In this diagram, each carbon atom forms 4 sigma bonds. Let me emphasize on sigma bonds and pi bonds. Let's consider C for example. Carbon atom. This carbon atom can be bonded by 1, 2, 3, 4 atoms of hydrogen. So in the event where we have H here, H here, H here, H here, we can say that this carbon atom has 1 sigma bond here and another sigma bond here, another sigma bond here, another sigma bond here. So the total number of sigma bond in this carbon is 1, 2, 3, 4. This is single bond. So we have 4 sigma bonds. Also, let's consider another example where we have a carbon atom with 1, 2, and 3 bonds. Now, observation, in this diagram, we have 1, 2, 3, 4. Over here, we are having 1, 2, 3. So if we come across a carbon atom with only 3 bonds, that is to say, it is an alkane. So this is double bond, carbon-carbon, double bond. The bond that was meant to be written here is taken to the center, making it double bond. So we have 1, 2, 3, 4. So to determine the sigma bond, we have 1 sigma bond here, and 1 sigma bond. Because there's no sigma bond under here, we can say that this is a pi bond. Take note of this. So in this diagram, we have 1, 2, 3 sigma bond and 1 pi electrons or pi bond. Also, let's consider another diagram. If we have 1 carbon and 1, because there's no bond at this point, also at this point, we can say that this is a triple bond. 1, 2, 3 plus this, which is the total number of 4 bonds from carbon. So the total number of sigma bond is going to be 1 here, another 1 here, because this position and this position is without a bond. Let's call it a pi bond and pi bond. So in this diagram, we have total number of 1, 2 sigma bonds, 2 sigma bonds, 2 sigma bonds, and 1, 2 pi bonds. So take note of this concept. Haven't known this, let's consider or apply the hybridization rule. In hybridization rule, if we have 2 sigma bonds, the rule says that this is going to be categorized under sp hybridization. Also, if we have 3 sigma bonds, the rule says that it is going to be categorized under sp2 hybridization. And also, if we have 4 sigma bonds, the rule states that this will be categorized under sp cube sp3 hybridization. Haven't known this, since each carbon in ethane has 4 sigma bonds, since each carbon has 4 sigma bonds, 1, 2, 3, and 4, and this is what we call carbon-carbon single bond, and which is the best example of alkane. So since each carbon in alkane has 4 sigma bonds, each carbon is sp cube hybridized. sp cube hybridized. For clarity, let's consider this formula for ethane over again. So we have sigma bond here, 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 sigma bond, sigma bond, sigma bond, and okay, that is it. So in this carbon atom, we have 4 sigma bond surrounded by this 1, 2, 3, 4 surrounded this carbon. Also, in this carbon, we have 1, 2, 3, 4 sigma bonds surrounded this carbon. That is to say, each carbon on this diagram contains 4 sigma bonds, which is sp cube hybridized. Now the question is, let's return back to the question, what is the percentage S character in ethane? So now let us record that percentage S character, because we were required to determine what is the percentage S character of ethane. So percentage S character is equal to number of S orbital divided by total number of hybrid orbital times 100. So this is the formula for percentage S character. Now, in this formula, let me emphasize in this formula, this means number of carbon over number of sigma bonds surrounded that carbon. So we have percentage S character is equal to one carbon was surrounded by 4 sigma bonds, then times 100, and we obtain 1 times 100 divided by 4. So 4 goes into itself 1, 4 goes into 100, 25, and we are left with 1 times 25 divided by 1. So the final result is 25%. So let's return back to the question. So in the question we have 20%, 33.3%, 25.0%, and 50%, and the correct answer is 25%. Up next, we have question VI III. The question is, give the IUPAC names of the structures of the following compounds. Okay. Now the first compound is this. Let's draw this. We have this, something in this nature, and this. Okay, that is exactly what we have here. Now, this is the same as, let me add a dot here, dot here, dot here, and here. Now, each of these dots represents alkyl group. Alkyl group. Alkyl group is CH3. Take note of this, CH3. So this can also be represented or drawn this way. So we have C, 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 and C, then C. And we said this dot represents CH3. So 1, 2, 3. H, H, H. 1, 2, 3. H, H, H. 1, 2, 3. H, H, H. 1, 2, 3. H, H. 1, 2, 3. H, H, H. So how do we name this compound? The first rule is that determine the total number of carbon chain, which is the parent chain. So if I move in this direction, I will have 1, 2, and 3. 1, 2, 3. Also, if I move in this direction, I'm going to obtain the same number of carbon chain or parent chain, which is 1, 2, and 3. Also, if we are moving in this direction, 1, 2, 3, we are still going to obtain the same number of parent chain. So we have 3, and this 3 represents propane. This 3 represents propane. Up next, so if I'm moving in this direction, 1, 2, 3, then I'm going to have this person, and this person is methane, and this person methane. So we are having 2 methanes as a substituent. 2 methanes as a substituent. So that will be, and the position of this methane is in the second carbon atom. In the second carbon atom, that gives 2 methyl, 1, 2, 3 methyl alkyl group. So we have 2 methyl. Then we also have 2 methyl here, 2 methyl. So the name of this compound becomes 2,2-dimethyl. Then you attach the name of the longest carbon chain or the parent chain to it, which is propane. So the name of this compound is 2,2-dimethyl propane. Let's consider the next one. Up next, we have this compound on the board. What is the name? Okay, the compound is this. One, two, three, four, five. Okay, 1, 2, 3, 4, 5. Okay, so over here we have the alkyl group or methyl, CH3. So this is methyl cyclopentane. 1, 2, 3, 4, 5 for pentane and methyl. So we have methyl cyclopentane. This is the same as 1 methyl cyclopentane. So the right name is methyl cyclopentane. Up next, we have 1, 2, 4 trimethyl cyclohexane. 1, 2, 4 trimethyl cyclohexane. Okay, we have 1, 2, for trimethyl cyclohexane. 1, 2, 4 trimethyl. Let's verify. All right, cyclohexane. The first thing we have to obtain is to draw the structure for hexane. And since they are saying cyclohexane, then it should be in this nature. But the difference between what we are about to draw now and this structure is that in this one that was written here, we only had 5 sides. 1, 2, 3, 4, 5. But what we are about to draw now is going to have 6 because 6 represents hexane. So that is, we are going to have this 1, 2, 1, 2, 1, 2. So we have 1, 2, 3, 4, 5, 6. Okay, 1. Let's call this 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we are going to represent our alkyl group or methyl in 2. Okay, 1, then 2 and 4. 1, 2 and 4. So let's put it here. This is CH3. This is CH3 and CH3. So the diagram will look this way. 1, 2, 3, 4, 5, 6. So we have CH3, CH3, and over here CH3. So this is called 1, 2, 4, 1, 2, 4 trimethyl cyclohexane. So up next we have 2, 2, 2, 2, 4, 4 tetra. In our next video, we are going to consider question number 2 and also question number 3, where we will be required to name this structure. So this is question number 4. We are going to provide the solution to this question in this paper. See you in our next video.